In this video, we're going to look at finding other missing dimensions on a 3D object if we're given the volume and all the other dimensions. Now, in the first example here, we're given the volume of the cone, so we're not being asked to find the volume of the cone in this particular example. That's given to us in the question, but we're asked to find the height. Now, a standard question would generally give you the radius, give you the height, and then ask you to find the volume. So this is kind of working backwards. We still need to use, though, the volume of a cone formula. So first thing I'm going to do there is write out the volume of a cone formula, which will be on your formula sheet. Volume is 1/3 pi r squared h. Now the next step in this question, after you've written the formula, and let's just put that up at the side, is to fill in all of the known values. And the known values in this case are the volume of the cone is 370 and the radius of the cone 6 centimeters. So we'll go through this formula a bit at a time. Start with the capital V here. Capital V for volume. We know the volume is 370, so we replace that capital V with 370. 1/3, that remains the same, it's a constant, times pi, times, and then we've got r squared. So do we know what r is? Down here we can see the radius is 6, so that's going to be 6 squared times h, and do we know what h is? And the answer is no. That's what we're actually trying to find in this question, so that's going to, at the moment, just remain as an h. So what we now have is we now have an equation which has only one variable in it. H is the only unknown value within this. Remember, pi, even though it's a Greek letter, it is actually a number. It's approximately 3.14. So the third step of this, once we've filled in all the known values, the third step is to solve this equation. Now, there are different ways to go about solving the equation, but the first thing I'm going to do generally, if I see an equation which has a fraction in it, the first thing I'm going to do is get rid of that fraction. So this is 1/3, so to get rid of this, I'm going to multiply by the denominator, multiply both sides by 3. So that's 370 times 3 at this side of the equation. And when I multiply this side of the equation by 3, all that happens is this 1/3 is cancelled out. So I'd be left with just the pi times 6 squared times h. Now, the idea of solving the equation, remember, is to get the h completely on its own. The thing that's preventing that from happening at the moment is the fact that it's been multiplied by all of this part here. So what I'm going to do is I'm going to divide both sides of the equation by what I've highlighted in yellow there. So if I divide the left-hand side by that, it becomes 370 times 3, all divided by pi times 6 squared. And when I divide the right-hand side by this bit I've highlighted, it simply cancels out the bit I've highlighted, leaving just the h. So the h goes in there. All I then need to do is then put that into my calculator. Now, we do need to be careful putting this into our calculators because there's quite a lot going on here. This at the top, they're being multiplied, at the bottom they're being multiplied, and we've got a square there, and we're dividing. Now, if I want my calculator to deal with this in the proper way, just to be sure, regardless of which model or make of calculator you have, it's a good idea to put the top of this fraction and the bottom of this fraction in brackets. And if you do that, your calculator should deal with it correctly. So typing this into your calculator with the brackets, remember it's just the top, and then you can just use the divide button for the fraction by the bottom. Again, bottom and top both need to go in brackets. And that gives us 9.81. And then we need the unit to go with that. Now, remember, h here is height, so basically it's a length. So the unit will just be plain, it won't be cubic units or square units or anything like that. It's just going to be centimetres or metres. So we'll have to look up at the volume we were given. The volume was obviously given in cubic centimetres, but it's the centimetres part I'm interested in here. So because height is just length, it's just going to be centimetres we have down here. In this example, we're given two shapes, a cube and a sphere, and we're told that they have the same volume. We're then asked to calculate the radius of the sphere. Now, to calculate the radius of the sphere, in other words, to find r, we would need to know what the volume is first of all. Now, that's where the question, will help us. It says the cube and the sphere have the same volume. So if I want to know the volume of the sphere to help me find the radius of it, then I need to first of all find out the volume of the cube, because these two will have the same volume. So let's start off with volume of a cube. We're going to do V equals length times breadth times height. That's a formula you will need to know off by heart. It won't be on any formula sheets. Volume of a cube or a cuboid And because it's a cube, remember, a cube rather than a cuboid, this is 2 centimetres, means this is 2 centimetres, then this is 2 centimetres. All of the sides on a cube, remember, are squares, so all of these edges are the same length. So that's going to be 2 times 2 times 2, or 2 cubed, which is 8. And that is cubic centimetres. Now, the question here says the cube and the sphere have the same volume, which means if the volume of the cube is 8 cubic centimetres, then the volume of the sphere is also 8 cubic centimetres. So let's just put that on there, and we'll say V equals 8 cubic centimetres here. The next thing is we're asked to find the radius of the sphere. Now, for the volume of a sphere, formula, which we'll need for this, is volume is 4/3 pi r cubed. And we're going to follow the same steps pretty much as the last example. So I'm going to write them down the side here. So we have write the formula, which we've just done. Step 2 is to sub in all of the known values. Now, in this case, we have V for volume and R for radius. There are two values. We need to see if we have either of them. V for volume, well, I know the volume of the sphere. We worked that out to be 8, remember, so I can replace the V there with an 8. So that's 8 equals 4/3 pi r cubed. The r, I don't have that value, remember that's what I'm trying to find. So the only value I really know or can add to this is V for volume. The next thing is we're going to solve the equation. Now this is obviously an equation, the only unknown value in this is r, so I'm going to solve for r. Remember pi, even though it's a letter, it is a constant value, it's 3.14 approximately. So what we're going to do is the same as before, we are trying to get rid of this fraction, so I'm going to multiply both sides by 3. So that side there will become 8 times 3. And the other side, when I multiply this 4/3 by 3, it will cancel out the division by 3 on the bottom here, and it will leave me with all the other parts. So 4 times pi times r cubed. Okay, so only the 3 at the bottom will be cancelled. So let's write that out. That's 4 times pi times r cubed. The next step is to try and isolate this r cubed. Now at the moment the r cubed there is being multiplied by this 4 times pi. So we're going to divide both sides by 4 times pi, which is going to give us 8 times 3 divided by 4 times pi, and that's going to give us r cubed. So before we go any further with this, what I probably want to do is just calculate what I've got so far. I don't want to do too many steps and build up too much at this side. So remember from the last example, if I'm going to type this into my calculator, a big fraction where there's a lot going on at the top and a lot going on at the bottom, put the top and the bottom in brackets. So that's going to give me r cubed is equal to, and when I type all of this into my calculator with the brackets, I end up with 1.91. And then remember what I've got here is I'm not actually trying to find r cubed, I want to know what r is. So if r cubed is equal to that, then r is the cube root. The opposite of cubing is the cube root of 1.91, which comes to 1.2, and the answer there will be centimetres because the radius is just length. Now I've just rounded that to 1 decimal place, but remember for units, we're trying to find r. R is a length, so it doesn't get cubic or square units because it's just length, it's just going to be centimetres. Okay, because the volume was given cubic centimetres, the length will be given in just centimetres.